Hey guys, it's Tuesday afternoon and I'm doing my video and I'm tired, so bear with me. Let's get through this. Hope you guys are having a great evening. Number one says solve the following system of inequalities. So the first thing we want to do is we want to graph them. So we're going to start by plotting the y-intercept. So the y-intercept is -4. 1, 2, 3, 4. Okay, so this is our starting point. Then we're going to plot our, sorry for the delay, there was an announcement. Then we're going to do the slope to get to the next point on the line. So remember, slope is rise over run. So since our slope is 2, we need to put it over 1. So from our starting point, we're going to rise 2, 1, 2, run 1. Okay, to get to the next point, we keep on with the same pattern. Rise 2, run 1. Okay, then we get our straight edge out. Doesn't have to be a ruler, but it helps. And we're going to draw a solid line whenever we see an equal. Okay, that means it's going to be a solid line. Just like that. Okay, now we have a less than symbol here. Less than. Okay, so that means we shade below. We shade below for less than. This is fun. I like shading. So the solutions to this inequality are all the points in the shaded region, including the points on the line. Okay, next one. Now, I'm going to go ahead and get a pen so that we can use a different color, sort of, for this one. So our starting point is at -5. So 1, 2, 3, 4, 5. So -5 is our starting point. Our slope is 1/2. So rise 1, run 2. Rise 1, run 2. Remember, always go from the starting point. Then to get to the next point, we rise 1, run 2. And you can do it as many times as you want. Now, if you ever want to go the other way, we would just reverse the order. Instead of rising 1, we would go down 1, and then left 2. Okay? And notice there's no equal sign. So this one is actually going to be dashed. A dashed line. So solid line, dashed line. So this is going to be dashed. Okay, and then it's a greater than symbol. So the greater than symbol is shading above. Above. Shade above. I should have put the shade above, the word above. But anyway, so we're going to shade above. So this is the shading. Okay, and so then our solution, it says to solve, our solution is going to be the area that the double shading, where it overlaps. So make that especially dark. So you know that all the points in this region right here, all the points in this region are solutions to both inequalities. So they represent the solution to the system. Now, all the points on the solid line are solutions. All the points on the dashed line are not. So when you look at the border, solid represents solutions, dashed does not. Okay, number 2. X is less than 6. So that's one of those vertical lines. Okay, so we're going to go to 6 on the x-axis. 1, 2, 3, 4, 5, 6. And then we're going to draw our vertical line. And there's no equal sign, so what kind of line do we do? That's correct, dashed. Okay, It says it's less than, so we're going to shade, well, which direction is less than 6? This direction or this direction? That's right, to the left. So we're going to shade to the left. So everything in the shaded region represents solutions. All of those points represent solutions to this one. Okay, now the next one is not in slope-intercept form, so we're going to have to do a little changing around. Okay, remember to graph it needs to be in y, mx plus b format. So we're going to move the x over to the other side by canceling it on the left. Bring down the y, negative x goes first, and then the 4. Now we got it in y, mx plus b format. That kind of looks like a 9. Let me fix that. Okay, let's go ahead and use a different color on this one. So starting point is 4, so 1, 2, 3, 4. Slope is negative 1 over 1. So we're going to go down 1, right 1. And we can continue on with that pattern depending on how many points you want to have. The more points, the more accurate it's going to be. Notice there's no equal sign, so what kind of line am I going to draw? Good, the dashed line. So it represents like a border. All right, it's greater than, so where do we shade? Above, perfect. All right, well this system has 3 inequalities, so we got one more to graph. One more to graph. Now I wish I had another color. I don't. So hopefully you can follow. This one we're going to have a starting point at 4. So 1, 2, 3, 4. So we're going to have a similar starting point. And notice this slope. Put the negative on the top number. Don't put it on both. Put it on the top number. So that way we know we're going to go down 1, right 2. So down 1, right 2. Down 1, right 2. Okay? Again, this is going to be a dashed line since there's no equal part. I'm really tired, guys. I just want to go home, rest. I haven't been feeling well today. Stomach, I don't know what it is. So we have a less than symbol, so we're going to shade below. This line here, we're going to shade below. And you probably can figure out, I wish I used a different color, but make it a little darker. Okay, so where do the 3 shadings overlap? Well, let's see. We got one going this way, got one going up, got one going down, so it's going to be all shaded really dark in here. This is going to be the solution. Let's see. Solution to this problem. That's where the 3 overlap. Now, are any of these borders, do any of these border lines have a solution? No. Why? Because they're dashed. Correct. So only solutions are those points inside this shaded region. Okay, the only thing challenging about this is that you're going to have to do a little maneuvering here of the equations. They're all in standard form, and we need them to be in the y, mx plus b format. Now the reason why I say that is because it's not y equals, they're inequalities. So y, mx plus b, the inequality would go in here. So let me get you started. Okay, so the first thing we want to do is we want to move that x over to the other side. So we're going to cancel it on the left. Remember, whatever you do to one side, do to the other side. Okay, so it cancels. Bring down the negative 3y greater than. I'm going to put the x term first because that's going to have the slope on it. And then the minus 9 is the constant that goes last. Okay, not done yet. We got that negative 3 to get rid of because we want the y to be by itself. So this is multiplication, so we're going to divide everything by negative 3. Okay, this is 1, so we got 1y. Switches directions because we divided by a negative. And two negatives make a positive, so I'm going to make this a 1/3 x. Got the 1 from here. Negative 9 divided by negative 3 is positive 3. So you can graph that on here, and I would like you to take a moment, if it's not too late. Yeah, you, Edgar. You better be in bed if it's 1 o'clock in the morning. Or 2, or whatever you said. Man, you stay up late. So go ahead and change these to slope-intercept form, which is this, and then graph them and finish that up for tomorrow. See you guys tomorrow.